Biostasis, yes. So my friend John Hildebrand called me up and he said, "What do you know about biostasis?" And I said, "Nothing much, but I like to learn." So I was Googling while I was talking to him, and he said, "Well, you know history, and you work on regeneration and related topics, so how would you like to give a talk?" And I said, "Fine." And that was last fall. I've done a ton of research. It's exciting what all falls under that umbrella, as was mentioned earlier. So I'm going to talk about the historical context, and then I was asked also to raise some ethical questions because the ethicist couldn't be here. So what is biostasis? A good place to start is, as usual, with the Oxford English Dictionary. And I don't like reading quotes at you, but sometimes words are important and it's useful to get it right. A state of stasis or equilibrium in a biological system. Well, duh. Okay, bio and stasis. But in which the organism remaining viable. It undergoes suspension of something. And it's interesting to look at different versions of OED and other dictionary versions. It's a suspension of life. It's a suspension of animation. It's a suspension of growth, metabolism. And each of these is slightly different. They're used as if they were the same, but they're slightly different. So there's much to talk about there. The term was actually used first in 1955 at a SIBA conference on aging, looking at the idea of biostasis of the whole body. And the claim there was the first use of that word, but that there was a concept that is woven into countless human beliefs. And so my approach here is to look at some of those countless human beliefs and look at some episodes in the history of thinking about biostasis. And these are not episodes that exist out there in the world that I've gone and found. I read a whole ton of stuff and then tried to put it in some kind of order. So here we go. So the empirical exploratory period. So at first it's discovering that there is a phenomenon that later gets called biostasis. So Laeuwenhoek is a good place to start. Laeuwenhoek writes a letter. Laeuwenhoek wrote lots of letters, as you know, often to the Royal Society. 1702 he writes a letter. Laeuwenhoek also had his little microscope, and he liked to go around and collect things and then put them in water and see what happens. So he goes to sediment of the roofs of houses. Okay, that's a logical thing to do, right? But he's doing everything. That's just one of the many things he's doing. So sediment from the roofs of houses, and he puts it in water, and he says, oh, look, there's certain animalcules that come alive. And we know from his pictures they're rotifers, little invertebrates, and tardigrades. Okay, tardigrades. So we have to say a little bit more about tardigrades. Water bears, they're often called. 1773, they're first described, actually. And these quotations are from headlines in things like Scientific American stories. And actually, a couple weeks ago, maybe you noticed New York Times science section had featured an article on tardigrades with a picture. That was very exciting. So it's been called the toughest creature on Earth. It can live in a space vacuum. Literally, we know that. It was set up in space in a vacuum with no oxygen, and it lived, came back, and was alive. It has an unusual genome. It can be radiated and doesn't really mutate, and it just is fine. So it's kind of a poster organism for biostasis in a lot of ways. I'm going quickly through a lot of things. We could say a lot more about tardigrades, but we won't. We'll move to Benjamin Franklin, appropriate, and his flies, appropriate, and Madeira, appropriate. So Franklin, in a letter, Franklin says that he has seen an instance of common flies that have been drowned in Madeira wine. So drowned, they're presumably dead. The Madeira was bottled in Virginia, sent to England. Franklin was in England with his friends to whom it had been sent. On opening one of the bottles, 3 flies fell out into the first glass. Now, what do you do when flies fall into your glass? Well, surely you say, I propose an experiment. let's take those drowned flies and see what they can do. So put them in the sun, and then in less than 3 hours, they began to recover life. So he's talking as if they were dead, now they're recovering life. So questions about when are things dead, when are things alive, how do we know? Okay, so they raised themselves on their legs, they wiped their eyes with their forefeet, they beat and brushed their wings with the hind feet, soon flew away, finding themselves in old England without knowing how they came thither. And then the third one, yeah, it died, we threw it out. Okay, but that was something that fascinated Franklin. So that's interesting, but even more interesting, as a letter he writes a little bit later, and says, hey, can't we do this for people? Yeah, I think it would be very much more interesting than having a normal death if I and some friends could be put into a cask of Madeira. And then 100 years from now in the future, when this country, so this is when the country's just getting started, when this country's developing, then I could have the solar warmth which would wake me up and I could see what the country was like. Okay, so that's fascinating. He's excited about this idea. And then when I was telling one friend about that, they said, what would he think if he were alive now? But okay, never mind. Okay, so there's this period of discovering that there's a phenomenon of biostasis, of the ability of something to be alive, seem at least to be dead, and then come back to life. Okay, that's empirically based. It's based on observation. But there's also this history, as the SIBA Foundation Symposium had said, of the sort of steeped in our social consciousness, fanciful discussions about this, and sort of a wish that it were possible that we could go to sleep and then wake up later, and things would be better or more interesting, or there would be the prince would be there in the Sleeping Beauty case. So these are just some examples among many. Mary Shelley, of course, Frankenstein, but wrote this story about Roger Dodsworth, the reanimated Englishman who comes to life later. A surprising one is Santiago Ramon y Cajal, Nobel Prize-winning neurophysiologist, you might say, neuroanatomist. He wrote a story, Life in the Year 6000, in which he's looking at somebody who's gone to sleep and they wake up, and what's it like, and what can we do with the brain, and what do we know about how neurons work and all that kind of stuff. Anyway, lots of examples, and Googling led to all kinds of actually horrifying science fiction. I don't like science fiction that much, so lots of horrifying science fiction stories about what happens when people are waking up. But so it's very much in the consciousness. We've had some examples showing that it actually exists, this biostasis phenomenon, all this fanciful thinking about how it might exist, and then it's worth looking in the 19th century, to the last half of the 19th century, efforts to explain, like, okay, there's a phenomenon, what is it? How can we explain it? So Claude Bernard, physiologist, French physiologist, studying tardigrades, says, okay, it's possible to suspend life. Like, how can this happen? It's possible to do it because they have an internal homeostasis. And what we need to do is study the biology to understand the homeostasis, understand what's going on with all the different parts and its interactions with the environment. When tardigrades are desiccated, then they have a sustained or sort of suspended homeostasis, but then it starts to carry us forward again. End of the 19th century, much discussion about spontaneous generation and actually regeneration, an idea of spark of life, which affects matter. And there is discussion about these apparently biostatic organisms being sparked back into life. So they're suspended, but animation it recurs. You get reanimation because of some kind of spark of life. For some, literally a spark, electrical spark. For others, some other process. William Morton Wheeler, studying ants, looked at the insect and especially ant development and says, there's a stage called diapause, which is when the normal processes of development slow down. And there's sometimes when they just pause because of external conditions. It's possible for that development to pause. What does this mean? How does it happen? There are examples in around 1900 and early couple decades in the 20th century of people trying to slow metabolism with coal because there was the idea that it could promote healing. So these are attempts to explain and do experimental work early on. People began to ask the questions, is suspended animation just a pause, or is there something different that happens when there's reanimation? That started to be an important question. Okay, Jacques Loeb, fascinating guy. If you don't know about Jacques Loeb, you should find out, because very interesting in a number of ways, including his interest in controlling life. And this excellent book by Philip Pauly talks about basically his history and his philosophical background. But Loeb says in 1902, I wanted to take life in my hands and play with it, to handle it in the laboratory as I would any other chemical reaction, to start it, stop it, vary it, study it under every condition, to direct it at my will. That sounds exciting. Sounds like what Dr. Becker's talking about in a lot of ways. And yet a lot of people are horrified by this idea. Like, wait, what? You're trying to control life in that way? So Loeb himself said, we have to ask, how far can we go? How far should we go? When is it okay to stop and vary life's processes? When is it okay to mess around with these things? So this engineering ideal or idea is there from the early 20th century, but also the questions about how far and where should we go. Okay, so there's a lot of history and a lot of things we could talk about, but I tried to talk about things that I think connect with what other speakers are going to talk about, so hopefully hit it a little bit. So medical intervention. So using biostasis for medical intervention, you've heard about ECMO already, 1970s especially. What happens in this case is that in a way, I say we, I'm not doing it, but we the people are displacing the normal processes in a way. So it's not that these organisms are dead quite, but when we're extracorporeally doing things with heart, lung machines, etc., we're displacing that function and in a way replacing that function. So is it exactly the same when we have this kind of biostasis? Are we having exactly the same processes going on? Is there something else that's going on that might be a little bit different, maybe better than what was normally going on? So thinking about what it is that we're actually doing is something that people have been thinking about for a long time, and hopefully, since I was asked to add ethics to my portfolio here, hopefully I'm raising some of these questions that we can talk about with the panel. So obviously this approach has saved many, 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 many lives. It's clearly justified to use it, but are there limits? Are there risks? When is it okay to stop these living systems or to displace the function? Second example of medical intervention with induced coma, and I love this picture because induced coma, here's this very relaxed guy in this room full of all kinds of equipment and no people, which is kind of interesting. But okay, it kind of evokes coma-ness, calmness. There's a long history of awareness of coma, even in ancient Greek times, trying to induce coma with drugs because it was felt that it could be good for the organism to be calm. So is induced coma a type of biostasis? It's a suspension of some processes, but is the brain doing the same thing it would have and just paused and going to start up again just the same, or is there something different? And there's a lot of use of the word resurrection here. We have induced coma, and then there's resurrection. Well, when you have resurrection, does it come back just the way it was, or is it different, are questions. And it matters because it matters how we treat what we think is there or what is actually there. Okay, and then biostasis as medical intervention, third case, last case, hypothermia. Hypothermia as a treatment. People were experimenting back at the beginning of the 20th century with using cold. Take that idea, put it together with the idea of the golden hour. So after World War II, emphasis on the golden hour. You get an hour on the battlefield. You got 1 hour. You got to save the soldier, or else it's too late. And you put those together, and you get this headline, which was a number of places: "Why DARPA Wants to Freeze Soldiers on the Battlefield." Okay, so there were questions like, why does DARPA want to do that? Or, oh yeah, that's an interesting idea. Let's freeze soldiers on the battlefield. Okay, and there's one story, and I won't tell you which magazine did it. It was supposed to be Scientific magazine, but which claimed that this DARPA approach, and I'll mention DARPA more in a minute, and you'll hear more later, but it mentioned that this is very much like Alcor. So Alcor, I'm more aware of Alcor than you guys probably, because it's in Phoenix. And about 50 years ago, they started freezing Ted Williams and other people. Oh, we're going to freeze people, or it's cheaper to freeze the head, so you don't have to pay as much if you only want the head or the torso. It's more expensive if you want the whole thing. Somebody asked, what does it cost if you want the lower part? Like you want the reproductive parts, and that was going to be cheap until they realized that affects reproduction. Anyway, Alcor has this thing and a claim about cryogenesis, and that these people or their parts are in these vats, and they're going to get, when we know how to do it, they're going to get thawed out, and then they'll come back to life. Okay, well, no, DARPA program is not the same as that, and we probably all can have a view about that. But okay, so this DARPA program is really interesting, and you're going to hear more about it, but I want to put it in this historical context here. So DARPA program in biostasis starts 2018. Aims to extend the time for life-saving medical treatment, often referred to as the golden hour, increasing survivability for military personnel with rough conditions that you get on the battlefield. So that's a goal of the DARPA program. And the program officer at the time wrote that especially what we want to do is engineer the molecular and the biochemical. Jacques Loeb would have loved this. He would have been so excited. He would have signed up, put in the first grant proposal, I bet. Anyway, so the idea that at the molecular and biochemical level is where things are happening. And our goal with biostasis is to control those molecular machines, all the molecular goings-on with proteins, et cetera, and get them to all slow their roll at about the same rate so we can slow down the entire system gracefully and avoid adverse consequences when the intervention is reversed or wears off. So it's an awareness that there are a lot of different parts. You have a complex system that's made up of a lot of different parts, and so if we can get all those parts kind of working together and slow them all down, then perhaps we can do more to freeze those guys on the battlefield and make them live longer. All right, so how is this going to happen? Well, the DARPA program, and again, we're going to hear more about this, but when I look at it from the outside, I see that program funded various things, including work in regeneration, saying how do organisms regenerate. And I just put one of my books here because we asked the question, what is regeneration? Because there's a lot of talk about regeneration and regenerative medicine without clarity about the definitions there either. But with regeneration, there's the idea that something's damaged, something's injured, and then the hope is that it will recover, and that it may recover just by starting up and doing the same thing it was doing before, only fixing the injury, or there may be something different that goes on. So this DARPA program about biostasis is funding regeneration work. Jacques Loeb would have loved it, as I said it. Yeah, as I said, he said by understanding biology, we can begin to control it, we can begin to save lives in good ways. But he also asked, how far should we go? How far can we go, and how far should we go? Okay, so therefore, biostasis, the idea has been around a long time, the word has been around a long time. It's woven into the fabric of countless human beliefs. And we've seen already, and we will see more, that we can do more and more with engineering, pausing, displacing, even stopping life mechanically. So biostasis undeniably happens. And then reflective questions, okay, when is it okay to intervene and control? Only in crises, like on the battlefield or when you have somebody in the emergency room, or is it okay for improvements? If you think of the Ted Williams frozen head case as an improvement, it's discussed that way on the Alcor materials, that it's improving life and that things will be even better for those people. And there was even for a while a sales pitch that you might want to be frozen before you actually die so that you can have a better life when you come back later. That's real. I'm not making that up. Anyway, so what are the risks? What are the benefits? Who decides? All of these are questions. I hope we can discuss them in the panel. So just to end, Franklin was intrigued by biostasis, intrigued by the idea of waking up in the future. Are we? Thank you.